Right, so next of Alan's repairs is a York JCB867. If I remember rightly, the only place these have a serial number, that would have said connect positive the right way round. Can't get the power connectors, so Alan's done that, and what else can you really do? I'm not sure I like flat screws instead of Phillips, but where's my screwdriver? Taking the precaution of opening it up. So these came out, would be 6 to 9 months after York 861s and 863s. And of course, everybody thought, ooh, another nice York. But no, they're not. They're a nasty York. So, is it something like a Murphy DS602? But I think at least it uses an LC7137 synthesizer. Got no circuit diagram, no nothing. I've got a copy of the instruction book on file, but there's no circuit in that. I've got to put the soldering iron on. So Alan's changed that capacitor. What does he say? Changed the one capacitor and put a mic with it. The mic will need wiring to suit the radio. Is it an unusual mic wiring? No, it's supposed to be standard Cybernet, looking at that. Alright, we'll get it connected to the test equipment. I've just got 10 minutes. It is Sunday. I've got 10 minutes between now having to set off for a church service. But rather than twiddle my thumbs, I thought at least we'd start this. Right, power supply on, 13.8 volts. And there we are. Meter lamp not working. There's no PA on these. Oh, I think it is. I think it's wired right. Testing 1, 2. It isn't wired right. What it is, the mic and the transmitted audio is keying up through the microphone. Did I say that right? So, if we're supposed to be on diagram 1 and Uniden is 2, yeah, well, we'll come back to the mic. I want to get on with the radio. I wonder if that's wired Uniden. It's a very thin lead that. I've got a suspicion it may not be screened, but we'll see. So we'll use our standard wired Cybernet mic. Testing 1 2, testing 1 2. So there we go, that's basically where we are. Right, let's see what it's doing. Switch picture in picture on. It's doing 2.4 watts. A bit less than a new radio. Doing 2.4 watts. And doing 2.5 watts. Back to channel 20. And it is 822 milliamps. And on low power, I've got nothing. Let's try again. So, deviation on this test meter, wallow, it's 2.4, which is where it should be, but it may not be, because that might be lying. We won't be doing the VCO because we don't know the method. If we ever had one of these which needed the VCO sorting, of course, I would work out a method to do it. But these aren't likely to get fiddled with, and they're not likely to fail on their own. So straight away it's off frequency 2779079. We'll bring it on frequency, and that'll save me setting the test set for receive purposely wrongly. Let's put the frequency counter on the inset picture. I'll leave it at that. Alright, we'll go to receive, and I'll now put that in the signal generator. 2779. Do exactly. Oh dear, that sounds awful. It isn't receiving, is it? I've just thought I'd check this with my walkie-talkie that the signal generator is actually working. There's no receive. Well, sounds for a start like that filter's broken. this is a badly corroded set, folks. Well, I'm going to start by changing this filter. I'll pause the video. Okay, back into record. So I've changed the filter, and although that's clearly is broken, but it might have just been made the set deaf or something like that. I can tell it is. But we've made no change to the actual radio. So what we're going to do, I mean, it sounds like the 455 kHz IF is not working properly, because it's not the right kind of FM noise. So we'll get our secondary signal generator out. There is dry joints on this somewhere as well. But I don't know whether the printed circuit board is so corroded that it's got things missing. So what we'll do, let's have a look and see whether 10.695 is playing up. So as I'm waving this around, and there's no 10.695 reaction. So let's see if we've got a 455 kHz reaction. So you can hear 455. A bit off frequency, but you can hear 455. So 10.695 is what's missing. So go back to that. And it's absolutely no whiny noise at all. So I have to look at what's happened to the 10.695. Of course, it would be a circuit, would be a radio where we've got no circuit, wouldn't it? So how's it generated? Well, a lot of sets, the synthesizer sends out the 10.695, but not always. So I'm not going to touch the VCO, they've never been altered. So I'm trying to find where the 10.695 filter is. So we've got a kind of point to look for. So, you know, you might think, well, it's as deaf as a post. I'm putting a whacking great big signal in, and perhaps the transistors are no good in the front end. But we've got 10.695 missing, so that's the truth of the matter. I just can't see where the filter is. Anyway, you don't have to watch me trying to find the filter, so I'll pause the video. So in trying to track down some kind of data, I took a photo of the radio in the hope we can get it working and fill in the blanks. So then I compared that with what I had on file of the Murphy DS602, and it's identical. So you've got the two filters, the MC3357, just the same. I'd already done a screenshot from one of my previous videos, which was that. We've got a photo of the underside of the printed circuit board, and of course that one's in lovely condition. And then what I've looked at is the JWR M2 and the Icom ICB1050. Remember that Icom CB has nothing to do with Icom, who make ham radio equipment. It's just a fake name on it. It's no more Icom than Hans Christian Andersen com. Now those sets have a different synthesizer, but are more or less the same and clearly come out of the same factory. So if we ignore the synthesizer, this should be the similar circuit arrangement. You can see we've got the three different filters, and you have 1, 2, 3. There's the 10.695 I couldn't find. So you know what, chances are there's a transistor gone down. So we know the 455's working, but with the 10.695 isn't. So I'm going to have a look into that and try and work out what transistors failed. Okay, I'm going to be talking to myself for 10 minutes. So what we've done here is to change the board. I had a scrap chassis in one of our storage bins from 20 years ago. So it's not a recent purchase or even a recent gift. It is from 20 years ago. And the reason we scrapped it is because the audio IC was faulty. These sets being not good performers, these chips were quite expensive, like £13, and to do that and add a service charge on for doing it was more than what the set was worth 20 years ago, and it got scrapped. Subsequently, it had its channel selector board pinched for whatever reason. So we've taken the channel selector board out of Allen's. That he's still got his audio chip there, and we've put the new one in, as I say. But the reason is Mr. Chippie I decided that because this board is so corroded, all these black bits on the printed circuit are corrosion where it's gone through the solder screen. So we don't know whether the malfunctions, and bearing in mind there's no service manual, we don't know, it's just how that's just coming off just like that. We don't know whether the malfunction is because of a component fault or because the printed circuit board is open circuit with some of the tracks. Americans can say tracers, we say tracks. So this is arguably a slightly better front, and it isn't bent where the socket is, where Allen's is. So that's better. So when I did this, put this set on initially, it was doing 3 watts. So his was doing 2. So again, we're heading in the right direction. I've done a lot of photos of our donor set. Sorry, I'll start again. I've done a lot of photos of our demonstrator set, which is in perfect working order. We've got the front panel wiring, wanted to look at those. We've got the channel selector board wiring, and I must have missed a wire up because I've got no LED display at this stage. We've got the main board wiring. I haven't got that brown wire on. Straight away, that could be one reason things aren't working as we'd expect. No brown wire. So where does that go, folks? the brown wire. So we've got no ballast resistor for the lamp, so they must be using a 14 volt lamp. We're using a 12 volt lamp, so I need to add a ballast resistor, so I can't light that up at the moment, or it'll be like a car headlight. So I've got no display. I don't want to be moving this around and straining the wiring. I've got no brown wire. I'll look at that into our demonstration. The only thing not working on this at the moment is the display. I can even do the on and air test without display if we run out of time. So, because this is day 3 of this, it needs to move, or we get nothing else done and nothing for any other customers. So we've got received audio there, and if I put the signal generator, if I put the frequency counter up, which is there now, we've got 2779129. So I just set that when I was talking to the camera, and with the other set, this is now all through the window. Let's have a look. I'm only going to be able to test channel 20 without a display, otherwise I'll be faffing around. I just want to get on with the job. So we want high power. And it's doing 3 watts dead. Oh, I was doing 2.4 before. We've got a bit of a gain. Obviously I'd like it to do at least 3.6. So our transmitter lineup is going to be across there, and our receiver lineup is going to be across there. The detector's one of those. I hope that's not a VCO one. No. So we're still at 3 watts. Oh, I haven't got picture in picture on the right camera. So 3 watts. It's not that one. .5 watts. Fancy the pre-driver being out. .6 watts. It's probably about where we'll be. You know what, it's just doing 4, but I can't check on the other channels at the moment. It's not going to be far out. It's just right 3.95, so good. And as it cools down, that will be 4. So that's a good start. Now, which preset does what is another matter. I would suspect those to a meter. I do not want to tilt this up, but I'm going to have to a bit. So at the moment it's reading 4.5. So which is the RF meter? I mean, I'd expect it to be there, but then on the other hand, I've got 2 together. It is that one. When I've put the front on, I'm going to do that. It's not really safe to just do a little diagram here. So we've got the screen, got a preset there, got a preset there, got a preset there, we've got a preset there. So we've got RF meter. So what else have we got? So I don't think we've got low power. I think you get what you're given as far as that goes. I would think that's going to be the S meter on receive. So we're going to have squelch, we're going to have deviation. That's probably deviation. Just look at the photo to make sure I'm not overlooking something. So RF meter, I think S meter, I think squelch, and I think deviation, and I can't see any more. Let's see where the deviation is. Wallow. It actually says 2.2, so that's it's probably okay. Let's just listen. Testing 1, 2. Yeah, beautiful. I'll check it with the meter behind when I've put this together. That leaves us with doing the receiver. So we'll put the right frequency in the signal generator, 2779125. But absolutely nothing. Why would that be then? Because it was working a treat before I swapped the fronts over. Channel selector board. We are still on channel 20, aren't we? Yeah. Well, it looks like we're going to have to put a bit more of this together for us to have anything on receive, but it was absolutely spot on before I changed the channel selector board. Right, we'll pause the video. Okay folks, it's now Friday and we have been 2 sessions a day all week on this set. So to recap, I don't know what we've said in the video. We've changed the chassis from his corroded one to our previously scrap set, and that's his front, which is bent, and you can see it's had that damage there and it's very corroded. And our one still hasn't got the best front in the world, but is a better front than the one provided. I need to pinch the window out of this one. Now, our scrap chassis didn't have a front. This front is a front I bought in a batch of fronts some years ago. And what's always disappointing when you buy boxes of fronts is you get illegal set fronts which have to end up in the bin. Unless there was a way of sending them back to America. Right, so we now have a set that works. Everything except the receive light. I doubt that's the LED. But I might have to take the front off just for completeness, but I might not. It depends how I feel. Right, we'll only be charging the customer a token fee because obviously this is the kind of work that's gone into this. Even if we were charging half minimum wage we'd be at 100 quid. So, wow, right, so here goes. We can now do a tune-up, except the piece of paper is elsewhere. we've got 3.9 watts. See if we've got deviation. Wallow, we have. See how if it says 2.5, so it's right. Testing 1 2, testing 1 2 1 2. This set was scrapped because of its audio IC. At the time, those were 13 quid. That wasn't worth fixing. One of our viewers has sent 2 of those audio ICs as a free gift, and so therefore that free gift can be passed on. So it makes it viable even if we just charge a token fee. So it's quite possible that the transmitter was sorted out and the receiver wasn't. Now I know it's receiving. We'll put the signal generator on. And that's 1 microvolt we're hearing without it being any adjustment. So this is the first time I'll have ever heard audio out of this particular set. I've put a 1000 microfarad capacitor in because he'd put a 1000 microfarad new capacitor in, and so that's like for like. I'll have to go and get the paperwork and then we'll get on with the tune-up. So the only other thing to do, and I've just been to Grantham and back, so that was an hour and a what's it time. The only thing to do now is to do the tune-up, and we've got to fit a meter. We've got to wire up the meter lamp, because on these sets it's 14-volt lamp, which we haven't got. So we're putting a 12-volt lamp in, so we're going to have to put a dropper resistor or a ballast resistor, which we need to calculate. So we're going to come to that, and I've actually bought a pink calculator. I watched some of Big Clive's things, and he's got a pink calculator, and I wanted a pink calculator. That came from China, from AliExpress. Okay, so we're going to. Oh, I went to get the paperwork, didn't I? So looking at the circuit diagram for the Icom, which never was an Icom, ICB1050, which is, I say, similar, but except for the phase lock loop department. There's no sign of a receive light, and there's no sign of a meter bulb. So we'll just put that down because that was pointless. So here we go. So now with the substituted radio, we'll do a tune-up. Transmit. So we're actually at 4.2 watts. So still got to centralise it and make sure it's right. There. And then we'll be turning it down, I think, on this one. So we're at 4.4. That's 4. So that's the way we are on the other channels. It's exactly 4 on channel 40. And it's exactly 4 on channel 1. So it may be a bit of an also-ran set, but it's balanced very well. So on the other chassis, the one it came with, we couldn't get more than 3 watts. I was going to have to investigate why that was. So that's that. Low power. And we've got 900 milliamp. So 900 milliwatt, sorry, 900 milliwatt. So I don't know what presets what, but we'll see if we can find some of them. Probably Oh, I've got that circuit, but it may not relate in the component numbers. So, where's our transmitter? Here it is. So low power is achieved how? RV301. No, none of them are labelled. It's got a shadow of each component, but there's no component numbers. So you actually don't have any chance. So the presets we've got 1, 2, 3, 4. There are 4 presets. So have we got low power? So it's going to be that one. Yeah, it is that one. It's a bit dirty. .400 milliwatts. So there isn't a squelch preset on these, and the squelch is pretty lousy usually. The meter for transmit, we know which one that is. And I haven't done the lamp yet, we'll do that together. We want high power setting, so it needs to be the centre of the red zone. No, it doesn't. It is graduated 1, 2, 3, 4. It's actually virtually spot on where it should be. Again, that needs a bit of a clean. So this looks like 20 years in my storage shed. In a plastic bin, carefully labelled. A sealed plastic bin. One of those very useful boxes that are rather expensive but work well. So there we go, that's saying that. Doesn't have PA, so cross that off. We'll come to deviation at the end because it actually reads right. Just show you that. Well, the meter I don't think is working right just now. It did earlier. So low power is now 400 milliwatts, and the current consumption is 1 amp, so it's 1.006, which is pretty efficient, but then the meter's not lit up. That'll add 40 milliamps. So we'll come back to that. So let's look at receive. So I'll go over to the other speaker, which is still attenuated, so we unfortunately can't hear it as easily. I can, but you can't. Go over to the oscilloscope. See how easily that can distort. Go through the receiver front end. We'll go over to the synod meter and then we'll just see whether we can get a better waveform, which somehow I doubt. Wow. I don't know whether you've noticed, but it's nearly always the coil nearest the transmitter that's miles out, as if the screwdriver jockey has kind of done everything where they think the transmitter is. Let's look at the IF one here. I'm going to look at the waveform. No, I can't see any alteration in that. I think we're about there. I'm going to look at the waveform again here. I'm going back to the detector. I think that's the best compromise. There is a worse version, you know, and that's the Signal 1001. If I remember right, it's got a receive stage less. Okay, so let's have a look at S9. There we go, S9. Now it's the squelch. So I'll go over to the speaker we can hear. That just before you all think this is as deaf as a post, that's 0.3 of a microvolt. It's about 0.15 of a microvolt. I can hear this. So it's not that it's deaf. It's that it's noisy. And it isn't deaf at 1 microvolt. So back to the Cobra 29, that doesn't do 1 microvolt. So we've done that. Squelch isn't adjustable. You get what you're given. Okay, and what is it? 3. I could say a bit more than that actually. 3.5. This is not a suitable set for a busy town. Right, we'll see what the sensitivity is. So I've got the... Let's put that so we can actually see what I'm doing. Okay, signal generator back on. I mean that's lousy too. Let's just see if I can do a better job of setting the squelch. Let's have a third go at setting the squelch because that was too sensitive. It's 0.3. No, on the other scale it's 0.5. We'll give it the worst one, 0.5. So we've got his mic to do. I'll look into the receive light. So this is what we've got to do with the meter lamp. I think they're 40 milliamps, these lamps. I'm just going to turn the power supply down to 12 volts. Actually, I'm turning it down to 9. Let's take picture in picture off. So, if I can find our wire, all that needs to do is to go to the on and off switch to light up the meter. Now that's a bit bright at 9. So let's vary the power supply until the meter is the brightness I want. So here we go. So we're at 9 volts. I think about 5.8 volts, 5.9. So we'll call it 6 volts. I'll just take this back to 9 so I don't get confused in the future. Okay. So, still staying at 9 volts. I want to know the current. I think they're 40 milliamps. So we're putting the meter in. So you've seen what I've done there. I've got the brightness I want on this type of lamp. So put that into milliamps. And let's put the probes in series with the wiring to the lamp. Now then, does it have to go through maybe that one? It's actually .78 milliamps. So that's more powerful than I expected. So, lamp is 78 milliamps. And we said 6 volts was the best brightness. So, here's the pink calculator. So 13.8 minus 6 is 7.8. So we've got to get rid of 7.8 volts. So if we divide that by 0.078, we come to 100. So we need a 100 ohm resistor. Okay, we'll actually end up putting a 0.6 watt one in. So that's there. And when I switch on, hopefully we've got the right brightness. Well, we've got exactly the right brightness. Well done, Mr. Tango. No receive light. I have no idea why that is. And I've no idea whether it worked before we took this front board off. Here's set. The wiring is the green wire. Yeah, green wire goes to the green light. So let's see if anything actually comes out of the radio. I'll put the pink calculator to one side. Ohms. Well, you'd think there was power coming out. Well, we've got to take the front off. Simply to pinch the red lens for the display off Alan's original set. So we need to unsolder these, I'll take the power off, these capacitors again. That's the decoupling capacitors for the microphone socket. I've got an LED here, which is a red one off some scrap item. So just see the placement of these is very critical. You can see this red one is wired 3/4 of an inch to the left, and it's angled so that it goes into that bezel. It's like the printed circuit board wasn't designed for this front. It gives me that impression. I'll put the power back on. Might have to try and hold it on the other side. So it's the lower one. Once again, we'll get the test prods on this and see if there's actually any power to that. And the answer is no. I'll turn the squelch right down. Check again for power. No. Turn the squelch right up. Just in case it's squelch operated. There's nothing there, is there? So that comes definitely comes on the green wire. Just dislodge that, so we can see the green wire compare it with our other set. We've got an extra wire on the other set. No, we haven't. I'm telling you rubbish. I'm going to turn this one off, and we're going to turn this one on. So switch ours on, and ours has an awful why have I got no I've got no display. Why is that? Well, that's fun, isn't it? So taking the front of our demonstrator has oh, it's there's something loose. So look, the receive light is only when it's actually squelched. So when it's actually receiving and talking, the receive light goes out. That's the radio hissing. So when it's squelched, the receive light comes on. So that's an important thing to note. So let's see what voltage we've got. Yeah, I've got 2 volts there, and it's that way on, so I'll just change this negative to my left. So is earth being picked up there? I'll put earth to chassis. What I'm getting at is which one's missing off our set, off Alan's set, sorry. So put Alan's one on. Make sure the squelch is up to full, so the radio is not hissing. Yep. Same test again. We've got nothing. 1 to chassis. So it's the negative that's actually missing on Alan's radio. But we don't know where that comes from, because the nearest circuit diagram we've got doesn't seem to have a receive light. So back to, I'll just switch Alan's off so we don't short anything out with this metallic front. I know it's plastic, but that's because I've not got this. So where does the earth one come from? Well, that's the one that's connected to the green wire. Right. So if we just put that to rail voltage, that's I'll turn that one off. Okay, well I've spent 20 minutes on that and I haven't got anywhere. I don't know whether the fault's on the display board or whether it's on the main board, and without a circuit diagram I can't see how they're achieving it. So the LED doesn't do anything. It's not the LED that's faulty, there's no power getting to it. Sometimes you've got to draw the line. Right, see what the deviation is. Wow, it's absolutely spot on, 2.2 to 2.5. So what would normally happen is a set in this condition with all this corrosion would be returned as not repairable. So what we've done is to use a scrap chassis of our own, which had a fault of just being the audio RC, and then we've put our front on, which is a front I bought in the batch, but we've nicked his channel selector and his display board and his TX and RX light, so that's probably where the snag is. So we'll put his speaker on, we've just got to wire his mic to it, and then we can do an on the air test. So your York 861's a Cybernet, your York 863 is a Cybernet, this York 867 is a Korean made Billy No Mates, then the York 869 is the base station and is a Cybernet. So you've got three really good sets, and then you've got this one. There we go. See whether his speaker works. It sounds like it does. I mean, that looks like it's machine screws. But our demonstrator is self-tappers, the black ones. It's not these big ones, is it? I ordered the wrong size, and we've got a bag of, you know, probably about 17 quid a bag, seeing as they come from RS. Wouldn't it be nice if we found something that they fitted? Mr. Tango, we've actually found a set that fit. Well, that smartens it up, doesn't it? I think I ordered these intending them to go in Uniden base stations, and then they're too small. These are probably M4s. You wouldn't expect RS to put that on the bag though, would you? No, you wouldn't. Right, I'm going to put it on our aerial. Right. One niner, Roger. Good. Right, his microphone. So I think a lot of new microphones are coming wide Uniden. Oh, it speaks. So if it's Uniden, it's going to be receive PTT no, this isn't. It's if the colours can be believed. If the colours can be believed, is it wide great? I don't think these mics have a screen. I'm going to ascertain whether these mics have a screen. This is why I say you can't get mics at the moment, because the only mics I seem to be able to get don't have a screen, and I'm not prepared to buy them. I bought one and used it, but you know. It's not screened, it's just a curly cord. So there you go. So that's something which can introduce hum. Right, so we need to wire this as we need it. So we want the first pin, which is currently black, to be red. Probably best to take them all off. I don't think any of them are right. Right, our next one is receive. So receive on this mic is blue. And then screen, which it doesn't have, so we'll have the black wire. And then finally, the transmitted audio, the actual microphone itself, is the yellow wire. How many of you have done a really neat job of wiring a mic, then you discovered you haven't put the boot on, and you have to unwire it and it's never as nice and neat the next time? Right, well, I am convinced that's now correct. Right, put that together. I don't know whether there's a world shortage of screen cables, but that seems to be a problem. We don't have many mics left, and don't know what we'll do when I stop. We always used to have a mic wired for grandstand basses. Always had one available on eBay. Now I've taken it off because I don't want to sell any mics. I think we're down to half a dozen. Really? So he's on a farm, is he? And there's a cockerel. That'll be from Nottingham. Right, here goes.
Here we go, exotic fruits.
Keys up. Go to channel 20, stick our walkie-talkie on. Testing 1 2, testing 1 2, 1 2 1 2, 1 2 1 2. And there is a nasty hum, and that's because there's no screen on the mic. 1 2 1 2. So if we go to low power, 1 2 1 2, 1 2 1 2 1 2, there's less of a hum. So let's go to our mic with its screen lead. See whether that's any better. One two 1 2, testing 1 2 1 2, testing 1 2, testing 1 2. Yeah, it's better. Again, these are set, and the Murphy DS602 and all the rest of them. If you're running the mains, especially, you'll get a hum. And with that mic, it's going to be interesting at the end. We've proved there is no screen on this lead, so it's just 4 wires. Right, we'll do an on-the-air test. Thanks for watching. Don't know how many, whether I can cut this down to 1 hour on the edit, but say it's been a 5-day job at 90 minutes a day. Thanks for watching.